In A-level maths and also in further maths, we look at summing series. In A-level maths, it tends to be arithmetic and geometric series. But in further maths, we look at a series where each term is an expression in terms of the position number. And what we're looking at today particularly is using method of differences with partial fractions. So 3 things there that we're going to look at together now. First of all, sum of series. You should have come across already finding the sum of series using the standard formulae. What we've got here is we're being asked to find the sum of the values between 1 and n, where n is an integer. And each term in the sequence is r. So for the first term in the sequence, r is 1. The second term in the sequence, r is 2. And so on, all the way up to, if n was 20, would be 1 add 2 add 3 add 4 add 19 add 20 and stop. And what this is giving us is a formula to calculate what that sum is without going through each term in the sequence and adding it up. So if r is 20, then we can work out r by using this formula and subbing in our value of n. So it's going to be 20 times 21 all divided by 2. Similarly, if each term in the sequence is r squared, and again we'll take n, our final value is 20, then this time we're working out 1 squared plus 2 squared plus 3 squared and so on up to 20 squared. And we could work that out, but it's certainly more efficient to use our formula 20 times 21 times 41 all divided by 6. And similar for r cubed, 1 cubed plus 2 cubed plus 3 cubed and so on. And if n is 20, then it's much simpler to work out 20 squared times 21 squared all divided by 4. Let's look at an example. So it's not just r cubed, it's not just r squared, but it's a combination of them. And so what we can do, we say, right, we can work them out separately. And so between r is 1 and r is n, we know the sum of r cubed. We know the sum of r squared. So if each term has 5 times the sum of r squared, altogether we'll have 5 lots of the sum of all of those r's squared. Do you remember how to do the last bit? We've got n terms in the sequence, and each term has got a 2 added on. So altogether we've got n lots of 2. But there's other series that we have to find the sum of in further maths, and they don't always fit in with these standard formulae. Let's look at an example. You can see here's an example. We don't have an r or an r squared or an r cubed. But what we do have is we've got 2 fractions, both with an r in the denominator, and we're finding the difference between them. It's a subtraction. And when it's like this, then we can use the method of differences. Again, something you should have come across before, but let's remind ourselves of it. We start off by looking at certainly the first 3 terms in the sequence. We know the first term, we sub in r equals 1. So that's what we'll get. Second term, sub 2 into the formula, and that's what we'll get. Sub 3 into the formula, that's what you get. The examiner is looking for you to do at least the first 3 in the series. But usually, after you've done the first 3, then you're going to be able to start cancelling values out. Remember that in the series, what we're talking about is our first term added to our second term, added to our third term, and so on. But if we add these together, then what we find by comparing the first two terms is that in the first term we've got half subtracted, and then we add the second term, it's a half added back on, and they of course cancel each other out. Compare the second and third term, and again you can see there's a value which cancels each other out. You can think ahead, the fourth term in the sequence, we can see that that's going to cancel out that, take away a quarter as well. All that we're left with there is the first part of the first term, 1. We're looking for now for the last 3 terms in the sequence as well. So the last one's going to be n, so the previous 2, you can see what they are. And again, we can sub in for r, n minus 2, sub in for r, n minus 1, and n. Once again, most of these terms are going to cancel out. So if you're looking at the last 2, we've got 1 over n, and a subtract 1 over n, they'll cancel out. If you want to leave previous 2, there's another pair that cancel out. Back to the term previous to this one, you can see that that term will cancel out. But all we're left with all those cancellations, is the first part of the first term and then the last part of the last term. So we can say this sum between r equals 1 and n of the expression there. And there we've got it. Very simplified expression. We've used the method of differences to find that. So here we have an expression which isn't in the form of 2 values, or finding the difference between 2 values. So what can we do? Well, if it was expressed as that, then we could use the method of differences. And you'll probably in the exam you'll be asked to find one where it can be expressed as the difference between 2 fractions. So how are we going to go about that? Well, we do it by using partial fractions. This is a reminder of partial fractions. We've got our expression on the left when we split the 2 linear factors and turn it into a fraction with each of those as the denominator. So how are we going to work out our values of a and b? Well, more than one way to do it. We can compare coefficients of r. This is what we've done here. So what we've done here is we multiplied through by the denominator on the left, and so we're left with 1 on the left, and on the right, that's what we get. Then we can use coefficients of r to help us find an equation in terms of a and b. There's no r's on the right. When we expand the brackets on the, there's no r's on the left. When we expand the brackets on the right, that's what we'll get in terms of r. So we know that's true. We can then sub in a value of r equals 0, and that's true. And then we can use our equation 1 and sub in where we've got an a in the second one, we can sub in r minus b. That gives us an equation from which we can work out b and subsequently a. So because we've got those values of a and b now, we can evaluate our partial fractions. So now you'll see that our expression that we started with can be expressed in terms of the difference between 2 fractions. So this means that we can use the method of differences. So we use the method of differences on this, and so the first 3 terms in the sequence, sub in r equals 1, sub in r equals 2, sub in r equals 3, and that's what we get. And straight away we can see that there's terms in values in consecutive terms that will cancel out, and that minus 1/7 will go as well. So we've done the first part of the final answer. We're going to have a quarter in there. How about the last 3 in the sequence? sub in n minus 2, sub in r equals n minus 1, and for n. And again, we can see straight away there's pairs of values which are going to cancel out. 1 over n plus 1 will go as well with the previous term. So all we're left with is what we've got at the end there. So our final answer, if to find the sum of those values, a quarter minus 1 over n plus 4. You might get asked to evaluate it for a given value of n. Suppose n was 10. We can sub in, instead of n in our answer, we can sub in 10. So a quarter minus 1 over 14, there's your answer.